Hi, and welcome to Trig Formulas Day 9. Today we're going to be solving second degree equations, meaning we have an exponent of 2, or a quadratic equation. First, we're going to just start off with factoring. If I have 9 cosine squared theta minus 25, that's really no different than saying 9x squared minus 25, and you would recognize that as a difference of two perfect squares, and you would factor that as 3x plus 5 and 3x minus 5. So applying that same logic, we have 3 cosine theta plus 5 and 3 cosine theta minus 5. For number 2, we have 2 sine squared theta plus 3 sine theta. This would be like saying 2y squared plus 3y. Well, in that one you can see that there's a GCF of y. So in this case we're going to have a GCF of sine theta and be left with 2 sine theta plus 3. For number 3, that's a quadratic. That's like saying x squared plus 2x minus 15. So I'd have to find factors of 15 that subtract to give me 2, and that would be 3 and 5. This would be the tangent theta plus 5 and the tangent theta minus 3. Alright, for number 4, we need to do this by grouping. 4 times 1 is 4. The factors of 4 that give me 3 are 4 and 1. So it's going to be 4 cosine squared theta minus 4 cosine theta plus cosine theta minus 1. Because I have my middle terms to be minus 3 when I add them together. So I'm going to group and group. Here I'm going to factor out a 4 cosine theta, and I'll be left with cosine theta minus 1 plus, the only thing they have in common is a 1, cosine theta minus 1. So they both have a cosine theta minus 1 now. And when I factor that out, I'm left with 4 cosine theta plus 1. For number 5, again, that's factored by grouping. 3 times 2 is 6. My factors of 6 that give me 7 are negative 6 and then negative 1. So this is like rewriting it as 3 sine squared theta minus 3, actually minus 6 sine theta minus sine theta plus 2. And my grouping here, I have a GCF of 3 sine theta, and that will leave me with sine theta minus 2. And here I'm going to factor out a negative 1, so I'm left with sine theta minus 2. So my sine theta minus 2 is my new GCF, and I'm left with 3 sine theta minus 1. All right. So for the next question here, what is the difference between factor and solve? Well, solve has equals 0 or equals some number. We don't know what that number is. If you don't have an equal something, you're just factoring. You're not finding an answer. You're not finding an x, so to speak, or an angle in this case. For 3, part 3 here. I know my numbering is kind of funny. I think it's supposed to be part 1, 2, and 3, and then I changed my mind. Anyway, find theta to the nearest degree between 0 and 360. So we don't have to turn anything into radians. That's the good news. We have tangent squared theta plus minus 5 tan theta plus 6 equals 0. Well, I'm just going to factor it. What are my factors of 6 that add up to negative 5? Well, it would be negative 2, negative 3. So tan theta minus 3 and tan theta minus 2 equals 0. So then set each factor equal to 0. So tan theta equals 2, or sorry, 3. And tan theta equals 2. So on the calculator, to the nearest degree, so it says nearest degree, my reference angle here would be theta equals 63 degrees. And for this one here, my reference angle would be theta equals 72 degrees. Since these are both positive, we're only going to be in quadrants 1 and 3. So in quadrant 1, theta is equal to 72. And in quadrant 3, theta is equal to 180 theta plus 72. That'd be 243. Oh, sorry, 252. That's the wrong thing. And then over here, quadrant 1, theta is equal to 63 degrees. And then in quadrant 3, theta is equal to 180 plus 63, which is my 243. So all of my answers in set notation would be 63 degrees, 72 degrees, 243 degrees, and finally 252 degrees. For number 4, sine squared theta plus 5 sine theta plus 3. Well, I can tell you right now there's no factors of 3 that add up to 5. Since I can't factor, I have to use my quadratic formula. A is 1, B is 5, C is 3. Normally we would say x equals negative b. Well, in this case it would be sine theta is equal to negative b plus or minus square root of b squared minus 4ac, all of that over 2a. We haven't seen this in a long time. So sine theta is equal to negative 5 plus or minus the square root of 25 minus 4 times 1 times 3 is 12. All over 2 times 1 is 2. So this is 5 is equal to, negative 5, sorry, is equal to plus or minus the square root of 13 divided by 2. So we will have sine theta equals negative 5 plus radical 13 over 2, or negative 5 minus radical 13 over 2. Over here on the left, sine theta is equal to negative 0.6972. And over here, sine theta is equal to negative 4.3028. But I know from yesterday and from my graphs that sine has to be between negative 1 and 1. So this one won't work. We have to reject that answer. So to find my angle, theta is equal to, you just do second cosine of a negative point, or second cosine of 0.6972. Keep it positive so you have your reference angle. So theta is equal to 44 degrees. This is my reference angle. And this is a negative value. And since that's negative, that means I need to be in quadrants 3 and 4. So in quadrant 3, theta would be 180 plus 44, which is 224. And then in quadrant 4, theta is equal to 360 minus 44. So this is equal to 316. So as an ordered pair, it would just be 224 and 316. Alright, so the only thing different today is that we are adding factoring and the quadratic formula. Alright, good luck with that.